In this video, we'll be looking about the bug bounty architecture 2.0. Okay, so if you remember, like in previous video, we have talked about how an architecture of an organization or any target that we are targeting look like. Okay, so in this video, we'll go a little deep inside that. Okay, so what we'll be doing is I will talk about multiple bits and flavors. Okay, and why you are not getting any bounty because you're not even around that. Okay, so I will tell you like how the flow till it went, like when it starts from ground zero, the thing when you write code to when it go onto the market, and how does the flow look like? Like we will discuss about architecture in detail. Okay, but I would not say like in detail, because it might take more time. But I will tell you how does that flow look like. Okay, and you are here. Okay, you are again here. In the previous video also you were here. Okay, and again you are here. But this time I will tell you how the flow of the product look like. Okay. So let's say if you are looking for any target, okay, if you are hunting on any target, then what happens is this is inside the company. Okay, like any developer or coder. Okay, this is a company. Okay, and he will write some code. Okay, and once he writes some code, then what happens is he will submit it to QA. Okay, it will go via CI/CD pipeline, Jenkins, whatnot. Okay, and then it goes to the deployment. Okay, so deployment is where this whole thing is running, like container, Kubernetes, or whatever the orchestration engine they have. It will be running somewhere here. Okay, but the process to reach here, okay, the process to reach here is not that what we think. Okay, and we target directly this. Like let's say this is exposed by a gateway. Okay. And then as an hunter, you target directly here. Like let's say google.com is there. Okay. And when you type google.com, you will be hitting here. Okay. And then there is a problem. That problem we already saw in the architecture video one. And here I will be telling you about the attack surface, what most of the people will ignore in bug bounty. Okay. So what happens is, let's say if you are building any product or anything. Okay. So here you will write some code, and that code can have multiple technological nodes aspects of it. Okay, it will have a tech stack. Like it can be, let's say, Node.js. Okay, it can be plain HTML code. It can be Spring Boot. It can be, your what's a Golang. It can be some more technology. It can be Rust. It can be whatever. Okay, and this whole thing is the person who is working on does it. And then every product, whichever is built, will have few components. And when I say component, those are like the building block. It will have some authentication mechanism. It will have some authorization mechanism. It will have, let's say, some privileges way of doing things like super user, normal user, and something like that, which usually comes in authorization. Okay. And then this product is also delivered to QA, and then they will test things on it, and then this is also goes through the CI/CD pipeline, and then this is deployed. Okay, these are the various phases, and these are some of the block. Okay, so the major block of all of them is authentication and authorization. Okay, this is not an optional thing. So this thing is already there in all the application. Even if it is this, whatever it is, it doesn't matter. It will have that. Okay, so there are providers. There are OpenID providers. There is, there are OAuth2 providers. There is the other flows like client credentials and everything which comes under this. So there are providers which orchestrates your authentication and authorization mechanism. Okay, and in your code you use this mechanism to implement that. And once you are done with that, there are tools around orchestration. Okay, like deployment, which we talked about, like the Kubernetes, Docker, Jenkins for CI/CD, and then this whole thing, wherever it is running, it will have the other technologies which will help your product to, like monitor, create logs, and centralized logging. So it is like Kibana, one of the, like I'm just taking one of the tool. It can be anything like Kibana, Grafana, and then there can be Jaeger, and there can be few more. Okay. So this is what a product look like. Okay, your product is this, and what you have to understand is your bug or the attack vector that you are doing should be always around this. Okay, it's not here like scanning some directories or maybe scanning some open ports or doing things. This is secondary. Okay, first you have to understand this, because the thing is, even if you know about this mechanism, like authentication and authorization of the application, you will be already dealing with good bugs. Okay, if I would have to find bug bounty, like if I were to do bug bounty, then I would be learning. Like you can't learn all the things. Okay, definitely, but you have to know how these things are assembled, because what happens is when you do any code, okay, like whenever company releases some product or anything like that, okay, so what happens is this thing runs in background. Okay, whatever I just shown you, okay, like it's all there. Every company, like 99% of the company will have those. Okay, so they will write some code. Okay, and when you write some code, you will add dependencies, and these dependencies will be pulled from some artifactory. Okay, either it can be their internal artifactory, or it can be their external artifactory, or it can be global artifactory. It doesn't matter. But all the codes pull things from artifactory. Then, depending on how big is the artifactory, you pull lots of bits and pieces of code from there. It can be, your authentication mechanism. It can be your payment gateway. It can be your type integration, or it can be your logging mechanism. It can be, let's say, monitoring mechanism like actuators and whatnot. Okay, so they don't write code for all this. They do dependencies. Okay, they add dependencies. Okay, let's say if you want to have a payment gateway, or let's say if you want to integrate Stripe in your application, you add a dependency for Stripe. Okay, it's done. Your code will be automatically there. You just use few of the functions and it works. Let's say you want to implement a logging. Okay. So in logging, what you do is, let's say you want to log your application data, then you will use some of the libraries which is around logging. Okay, and it will make work for you. Then what you will do is, let's say you want to visualize data, you use Grafana. Okay, Grafana is for visualization. Okay, and from application side, you call it actuators, which actually send all this data to your endpoint, and that can be visualized by Grafana. So you don't write code for all this. You just add one line with the version number, and it automatically gets downloaded and it runs for you. Okay. So that is how, like most of the codes start with, and then you write the functionalities. The functionality can be anything, like what this application will be doing. What is the next step that you have to do when the person clicks on the button. So all those code is written in Java, whatever language they write it. But these are the building blocks, okay, of any application out there. Any application will have authorization, authentication, okay, and then logging, monitoring, okay, some Jenkins pipeline, some orchestration tool which is around Kubernetes, Docker, or whatnot, and then some other of the tools, like a lot of tools are there, okay, which companies use. So some Swagger dependencies, let's say, then they will have actuators. Okay, and then what they will have is, let's say, if you want to use integrations, like third party integrations for payment providing, like your application is doing some service model or something like that, and then you want to use Stripe, or let's say any other payment provider, then you will use payment provider. Okay, and then you will also have language conversion. Okay, so these are all the building blocks. Okay, and all of the application which is built on, now planet Earth, will follow this type of architecture, like 99%. Okay, so that is a usual flow. So whenever an application is built, right, whenever application is built, they do all this. They write the code, they build it. Okay, and while building, download things from external repository. All of this may be dependencies, and then they use Jenkins, okay, for their CI/CD pipelines, and it can be anything actually. Then they have all these things stored in their artifactory, which can be JFrog, okay, it can be any other artifactory as well. Then they have their Docker registry, because in Jenkins pipeline they create Docker images. Okay. And once you create Docker images, what happens is your Docker images are pushed to artifact, the registry. So this Docker image will be there somewhere in registry. Okay. I'll just clear this for okay. And I will tell you why I'm telling you all this in bug bounty because you are here. Okay. Because you are thinking you are finding bugs. Okay. And on the side note, this is what is happening in the company. Like the developer is writing code, he has added dependencies whatever he wants, then those dependencies are getting fetched from the third maybe internal repository, outer repository. It can be any of the tech stack that we saw: node.js, spring boot, like golang, rust, camel, whatever it is. Okay. And then it is sent to their CI/CD pipelines. The tool is maybe Jenkins, most of the majorly used tool, and that tool will help you deploy things and create Docker images. Okay, so it will help you create Docker images. So what is Docker image? So Docker image is just a way of running your application on, I would say, the global network, because Docker is well recognized, and if you are, it makes your like application independent of operating system, and that is the thing. And I will tell you about Docker and everything later if you want. So this thing is there, and the images which is created is stored on Docker registry. Okay, and the Docker is having a global registry which is dockerhub.com, and it can have their internal registries like docker.org.com or whatever they are. And then it will have the Kubernetes. Okay, so Kubernetes, it can be providers like AWS, GCP, Azure, whatnot. And then these providers can also give you an abstraction layer of help. So these things, whatever you are developing, can be deployed using help. Okay. And this whole thing can be hosted on any of the infra like AWS and all. And when your application is running, it might be throwing your logs, okay, to Kibana, which is Kibana dashboard, and Grafana. So Grafana is for monitoring dashboard. Okay, like what is happening with your application. So the thing is, if you see, I have taught, or even if you don't get anything, it's fine. But the words that I have used in this whole video, that is the actual target area. Okay, like if you are around that target, if you are actually dealing in bug bounty, if you really want to find bugs, if you are around those, okay, then only you will find bug, right? If you're not around this, if you're not looking, let's say even if you are looking for open port but you don't know for which service you are looking open port, it doesn't make any sense, because the purpose of ports is to be open. It is there for that purpose. Like, come on, like, it is there, right? It's there because that is a work of port. And if any service runs, it will open the port, but that is not a bug, right? So it is that way. So if your Docker is running, it has a default port. If your Kibana is running, it has a default port. If your Grafana is running, it has a default port. Your application might be using a database, like any application uses a database. So it will have a default port. If your application is an event stream, it will send data to Kafka. Okay, so that will have a default port. Kafka comes with Zookeeper, it will have a default port. And on top of it, this thing like Kubernetes has an API which you can call, that will also have a default port. Docker will also have a default port. Your registry server might be running on a default port. So the thing is, you don't have to go blind when you look for open port. If you are knowing about these services, you don't have to know all the services. But if you know, okay, these are the ports, you can target it, and you can actually target the literally endpoints. Okay, I will tell you about all this in maybe the later section. But whatever tech thing I told you, the things are built on that. Okay, and if you're not around that, then means you're doing something else. Okay, you might be looking for maybe recon, open port, or something like that, some subdomain and domains, whatever. But the things, the playground is this. Okay, like you have to find bugs around this, dealing with PII. PII I will cover later, but this is how a normal flow in an organization look like. Okay, so I got this request from one of the student, so I just thought to add it so that it makes more sense. I will elaborate this maybe in future, going deep on how each component works. But that is where you have to look for the bug. If you're not looking bugs around that, then there is no bug. That's simple. Okay. And that's why I added this, because it is important. Even if you don't get this, it's all fine. You don't have to worry because you're not a developer. Okay. But if you are, you have to know all this. And if you are a bug bounty hunter, your attack vector should be at least targeting this one, like at least around here, like around somewhere. It should not be like, because you can run for your whole life in dark. Okay. But the problem is it has to have a direction, because you don't know where the light is. So this is the light. Okay, if you are putting efforts in this direction, figuring out things around this, then it does make sense, to have good set of bugs which can pay you. So I hope this is clear. This is not like the earlier video where I have just thought what not to do. This I have told you what you should be looking at and how to do it. So how I would cover later, but I hope this is clear. Thanks.